known solar systems in the entire Milky Way galaxy. The solar system came into being about 4.5 billion years ago when a cloud of interstellar gas and dust collapsed, resulting in a solar nebula, a swirling disk of material that collided to form the solar system. The solar system is located in the Milky Way's Orion star cluster. Only 15% of stars in the galaxy host planetary systems, and one of those stars is our own sun. Revolving around the sun are 8 planets.
Yeah, only 8 planets. What are they, Saleh?
Neptune, Uranus, Saturn, Jupiter, Mars, Earth, Venus, and Mercury.
So Pluto, you know, before 20 years from now, they consider Pluto with them. But in year, I think 2006, they dropped Pluto from this group. So we have Mercury, Venus, Earth, Mars, Jupiter, Saturn.
They just took it out, or is it still in it? But they don't.
It still exists, but it's no longer a planet. It's like a big body, but not a planet. You know? You understand me?
Yes.
Okay.
Planets. The planets are divided into 2 categories based on their composition: terrestrial and Jovian. Terrestrial planets, including Mercury, Venus, Earth, and Mars, are primarily made of rocky material. Their surfaces are solid, they don't have ring systems, they have very few or no moons, and they are relatively small. The smallest and closest to the Sun is Mercury, which has the shortest orbit in the solar system at about 3 Earth months.
Okay, let me ask you a question, Semi.
Yes.
Can we live on the surface of Mercury, planet Mercury?
No,
Why?
because it's too hot. You'll burn to death.
That's right.
Venus is the hottest planet, with temperatures of up to 867 degrees Fahrenheit due to an atmosphere of carbon dioxide and extensive lava flows. Next to this world of fire is a world of water, Earth. The water systems on this planet help create the only known environment in the universe capable of sustaining life. The last of the terrestrial planets, Mars, might have also supported life about 3.7 billion years ago, when the planet had a watery surface and moist atmosphere. Beyond the 4 terrestrial planets of the inner solar system lie the Jovian planets of the outer solar system. The Jovian planets include gas giants Jupiter and Saturn, and ice giants Uranus and Neptune. The gas giants are predominantly made of helium and hydrogen, and the ice giants also contain rock, ice, and a liquid mixture of water, methane, and ammonia. All 4 Jovian planets have multiple moons, sport ring systems, have no solid surface, and are immense.
Okay, boys. Let me tell you a very amazing thing. Yes, Harris, you want to say anything?
Mister, I want to tell you something.
Yeah.
You know, Plato was existed until 1930.
130 what?
1930. Not years ago. يعني, I forget what
Yes,
I was
I
saying.
understand you. What happened in that year?
Yeah, the scientists said because Pluto go at
Yes, you search
the
in
solar
internet?
system and come back, they say it's not from our solar system, and they say it's not. Then it's Plato go from our solar system.
Yeah.
Then we didn't see it.
It was in what year?
It's born about 4.5 billion.
Very valuable information. Thank you. Omar, yes?
Teacher,
Yeah.
but how did they like let Pluto out? Like how?
No, Pluto is still exists, Omar. but they don't consider it like a planet. It's a big body. That's it. But still in its place. Pluto. Let's see what is Pluto.
It's the same. It didn't move, but they moved.
This video is about why Pluto isn't a planet.
Yeah, I watch Bright Side.
Now listen up. My very eager mother just served us 9 pizzas. Ooh, yum. Hey, if you were in elementary school before 2006, there's a good chance you had to memorize something similar to that sentence. This mnemonic device was used to teach children the order of the planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, also pronounced Uranus, yeah, you can't hide from it either way, and finally Neptune and Pluto. Now, if you're currently in elementary school, you might be saying, wait, there were 9 planets? Before going back to playing Fortnite Go or whatever kids are into these days. So what happened to Pluto? It's not like it's gone anywhere. It's still out there on the edge of the solar system, as cold and far away as ever. So what changed? Well, Pluto hasn't, but our understanding of it has. We know way more about space than we did 100 years ago. Pluto itself was only discovered in 1930, so it's not like the planet lineup hasn't been modified before. Still, that doesn't change the fact that there's something inherently strange about a planet being demoted. Who even knew that was a thing that could happen? Hey, what do you think? Should Pluto be a planet, or is it right where it belongs? Give me your opinion in the comments. Things might get a little clearer once we figure out what the word planet means. The exact definition has changed a lot over time, but from the age of Galileo to the 19th century, it referred to any object orbiting the Sun. This might seem a little vague, but worked perfectly well until the year 1801. That was the year astronomers discovered Ceres, a planet in massive air quotes, orbiting the Sun halfway between Mars and Jupiter. You might recognize this as where the asteroid belt is. And it isn't because Ceres pulled an Alderon and broke into 1,000 pieces. If it had, I'm pretty sure kids would pay a lot more attention in science class.
Okay, that's it. So let's please, I'll take you in a journey. We're gonna see planet Jupiter and planet Saturn from our Earth here. It's a real thing. It's a real video.
We can see Earth. We're standing on Earth, right?
We're already on Earth, but we are going to use a telescope. You know what is telescope, Omar?
Yeah. Who doesn't?
We're gonna use telescope to see very far planets like Jupiter and Saturn. Look. It's a real video, a real video. Look, if we look at through my telescope, we can see this part.
This is the actual telescope.
Yeah. But we're gonna see the telescope with this boy. It's better than this. Look.
Telescope as it is. Here's a live view look at the planet Jupiter through my telescope as it is right now in the night sky. I can see it naked eye, of course. Look at that magnification. Look at the details on this.
It's like a point. When you see it from Earth, it's like a small point. Maybe you consider it as like a star, but it's not a star in real. It's a planet.
Surface of the planet. The 5th planet from the sun, the gas giant, the largest planet in our solar system.
Jupiter is the largest.
Yeah, Jupiter, of course, is the largest planet. Jupiter.
In this video, I'm going to take a picture of the planet Jupiter through my telescope. Right now, tonight actually, is the best time to take a picture of Jupiter because it's at
This is a very advanced telescope with this man.
opposition. That means that it's at its biggest and closest for the year as the Earth sits directly between the sun and the gas giant known as Jupiter. Wait, this is an astrophotography YouTube channel, right? So how come I haven't ever taken a picture of the planet Jupiter before? My first interest in astrophotography was photographing bright objects, the stuff I could see with my naked eye. The moon and the planets were right there. I knew exactly where they were and I wanted to see them up close and photograph them. In fact, one of the first things I did when I got my first telescope was look at the planet Jupiter through the eyepiece. And it was life-changing for me, quite literally. I had no idea what I was doing, but through that small telescope, I could see the cloud bands of Jupiter, the great red spot, the 4 Galilean moons orbiting the planet. There it was actually out there. It's real, in real time. But after I observed the gas giant through my telescope and both eyepieces that came with the telescope, something happened. I wanted more. I wanted to see Jupiter bigger and closer and in better detail. I felt like I had to show everyone so they could experience what I just witnessed. I didn't expect to get that urge. I thought I would see Jupiter up close, cross it off my list, another awesome life experience in the books. But as many of you have experienced, this led me down the astrophotography rabbit hole, or black hole. And I went deep into astronomy. I mean, really deep. Suddenly, a clear night took precedence over everything else in my life. Astrophotography forums and space documentaries and joining my local astronomy club. I became obsessed with space, and it was all because of Jupiter. But that's when things went in a completely different direction. I thought to myself, if it's so easy to capture a planet through the eyepiece of my manual telescope with a little point-and-shoot camera, what's stopping me from photographing a galaxy or a nebula? I began looking into what's needed to photograph a galaxy, and suddenly deep sky astrophotography became my new obsession. In photographing our solar system neighbors took a back seat. How could I let photographing planets fall so far down my interest list? Well, that ends tonight. I've got way better tools at my disposal now, and I have so much more experience than I did back then. I'm so f***ing excited. Here's the plan. I'll use the Celestron Edge HD11 SCT, my biggest, baddest telescope I have, with the most magnification, widest aperture. This telescope gives me nearly 3,000 millimeters of focal length to play with, so I can pull Jupiter in nice and close. The telescope will slew and track Jupiter via the equatorial telescope mount it's sitting on, the Skywatcher EQ8R Pro. Instead of a regular telescope eyepiece at the back of the telescope, I'm going to be using a dedicated planetary astrophotography camera, and that is the ZWO ASI 462 MC. This will allow me to capture full color images in one shot of this planet at a high frame rate. I'll take short video clips of the planet Jupiter using the camera through the telescope and hope that I get enough good frames where there's less turbulence in the air. Essentially, you take a video with lots of frames of the planet and just extract the best ones where the planet looks the sharpest. The software that I use to run the camera is called Firecapture, and it's got some great tools for framing and focusing up the planet, and of course recording those videos. It is a hot, humid night here in the backyard. As you can see, that moon is just trying to poke out from beneath the clouds. Jupiter will be up soon after that. Hopefully I can get a clear patch of sky where I can take a short video on the planet. I can hear someone laying down a thick bass line in the distance, and it sounds like Workin' for the Weekend by Loverboy. They're a local Canadian band, well, they're Canadian anyway, so it might actually be Loverboy playing somewhere. They're no Glass Tiger, but I'd see them. The best part about using an eyepiece to align the telescope mount first before you put the camera in there is that you actually get a live, real view of the planet yourself when lining things up. Right now I've got Saturn in the eyepiece. I'm gonna call my wife out to come see it. Can you come see Saturn for a second? Rudy, you stay. Stay. If I smell a skunk, you're not coming out. To the left of the moon there, see it? That's where you're pointed.
Yeah.
Now look through the eyepiece. Never gets old, eh?
Yeah. I see some moons. I see two. One to the bottom left and one to the upper right.
Okay, my turn. Oh yeah.
So other planets have moons.
Here's a live view look at the planet Jupiter through my telescope as it is right now in the night sky. I can see it, naked eye of course, through the telescope at almost 3,000 millimeters focal length. Look at that magnification. Look at the details on the surface of the planet. The fifth planet from the sun, the gas giant, the largest planet in our solar system. Just incredible to witness it at opposite. Fifth planet.
So this is a picture of planet Jupiter through this telescope. You know, planet Jupiter is
Teacher.
very far. Yes.
We can see Jupiter, but you need a microscope to see it more close. How you can see it from مرة بعيد, like so far? He's just seeing the
know.
white of it.
Because I said in the beginning of this video, this is a very advanced telescope, Omar. And it's a very expensive telescope as well. So if you try to buy it, you can see planet Jupiter like this from Earth. But
How do planets have more moons?
more moons. You know how many moons for planet Jupiter? It's
How
around
many
six.
more?
How many moons for planet Jupiter? Anyone knows here?
Yeah.
Who can tell me how many moons for planet Jupiter? Let's see how many moons for planet Jupiter. First of all, how many moons for planet Earth?
One.
Yeah, only one. And how many for Mars?
I think it's 4 moons.
How many?
I think 4 moons or 3.
3 moons for Jupiter?
No.
Let's see.
79.
Oh yeah, I think it's 3.
Can you search on Google, right, please, how many moons for Jupiter? Search on Google, please. I'll get all the answers from you. Now,
Teacher.
Yeah.
79.
Somebody he's called
79
Simply Fleece. He really traveled to space.
Jupiter have 60 moons. 60 moons.
For Jupiter?
79.
Have you searched it on the internet?
No, I didn't, but I know it from my book.
From your book? So Harris said it's 60 moons for Jupiter. Do you agree with Harris?
No. Wait a minute, I want to see.
Just search on the internet about how many moons for planet Jupiter.
79, I said.
79?
Yeah.
Wait, Mr.
Yes, mister.
Yeah.
It's 60 moons to Jupiter, the champion.
Mr. Mahmoud.
Yes?
60 moons.
Mr. Mahmoud.
Yes, I hear you. How many?
60 moons.
Yes, I hear you. Can you hear me?
I'm talking. It's me, Ibrahim. I'm
Right.
talking.
Yes, how many?
Trying to talk, so
Yes,
Please
Ibrahim.
How many?
How many
so look.
moons
What I make? What
I
could
know
I make?
it's 60.
does Jupiter have?
what I made is this gun.
79 moons.
Oh my God.
79 moons. You know how many Jupiter for Saturn?
Saturn.
Search on.
Read. It's in my book.
How many? 82
Six in my
moons.
book. Why?
For Saturn, it's 82 moons. 82, wow.
In my book, 30.
Teacher,
No. If you search on Google, you find the right answer. Yes, Ibrahim?
Yeah, I will go and search it again. Mars has 2 moons.
Mars has 2 moons. Yeah, if you write here Mars,
Yeah, it's 2 moons.
2 moons. Mars,
Oh, sure.
only 2 moons. And the shape of the moon of Mars is like this. Not like
It's an
the.
asteroid. It looks
Yeah, exactly. It's like a.
it looks like an
Or the
asteroid
moon.
is gonna fall.
It's gonna fall.
Teacher,
Yeah.
you know, something is protecting all of the planets and all of the galaxies. I forgot what it's called, but it's protecting because the asteroid doesn't come. It starts with something with O or A.
You mean atmosphere?
Yeah, that's protected. Yeah, atmosphere.
It protects us. It protects us.
Yeah, it's like a white planet. I mean, it's like a white blanket.
It's not a white. It's
It's like a blanket.
a blue
visible.
It's like, yep, it is like a blanket.
atmosphere.
They're not real. Blankets
It's
do
protected.
defend you from some
Let's see
protects
the atmosphere of
everything.
planet Earth. The atmosphere of planet Earth.
Not everything it protects.
Layers of the
What is the atmosphere?
Yeah.
Rocket equation.
You know,
It's a
it
beautiful thing.
protects for the astronaut.
No
to come.
astronaut.
Can I just say something?
Hi, it's Mr. Anderson, and this is Environmental Science. Video 4, it's on the atmosphere, which is the gas covering on our planet.
Before starting this video, I'd like to ask you a question. Why planet Earth look like it's blue? The blue color.
Because the water.
Because it's 75% water. Yeah, water.
75% water, yeah.
Remember, we live in the atmosphere, and as society gets larger, we're pushing against these planetary boundaries. And since the economy is pushing us towards that, the economy is going to have to bring us back. And a story that relates to this is the story of stratospheric ozone. We call that good ozone. It's made of 3 oxygen atoms, and it surrounds the planet, and it protects us from harmful UV radiation. But in the 60s and 70s, we were producing huge amount of CFCs. The CFC is this is an example. It's a carbon, fluorine, 3 chlorine molecules. It would also go into the atmosphere, get hit by UV radiation, kicks off a chlorine, binds to an oxygen atom, and now we've destroyed the ozone. And so you've probably heard of this hole in the ozone. This one's right here over Antarctica. What's going to happen if we don't have that protective ozone?